Hey there, class. We are here today to look at how to take two vectors, and these could be any two vectors that we deal with, and how we're going to actually add these together mathematically. So basically, these are the two vectors that I'd like to take a look at. The vector A, which is 12 meters at 40 degrees north of east, and the vector B, which is 14 meters at 20 degrees east of south. Now, the truth is, we have already actually done the drawing for this. So I'm just going to kind of go over to where we actually did that drawing and take a look at that. So here's what I expect. Here's what I actually expect the drawing to actually look like. And we did this back in another video where we were simply looking at how do these things add, and we did this in a graphical sense. We did this with a ruler and a protractor, but today what we're going to look at is actually how to do this mathematically. So I'm going to copy and paste this over into my screen, and I'll do that here in just a moment. Okay, so here it is. Basically, once again, what we're dealing with is the vector A and the vector B. And the issue that we have here, where these make no right angles whatsoever. There is no right angle here, there's no right angle here, there's no right angle here. And in a previous video, we learned that whenever we had right angles, that was easy to deal with because we could use Pythagorean theorem and sines, cosines, and tangents. So we are not able to use that in this case. There are, of course, things called the law of sines and the law of cosines, which would be applicable here. But what I'm going to show you is how to deal with something called components. So in a previous video, I looked at these very same two vectors, and I had found, whoops, let me put that back. I had found these vectors, the components of these vectors in another video. So I'm not going to take the time in this video to show you that. I'm going to pretty much copy these over and show you to where to pick up with here in just a moment. Okay, so what I've done is I have copied those components over where I found these in another video, and basically copying them into this table. Now, normally if I was doing this in its full entirety, I would probably actually have that work inside the table here, but since I've already done the work elsewhere, I'm not going to copy that over, but just kind of the results. So basically, here's the idea. We have, in fact, let me scroll over here just a little bit and zoom out just a little bit here. We'll notice that the vector A takes us 9.19 meters to the east. Then the vector B takes us, or sorry, for the vector B, here it is taking us east as well. So this vector here takes us east, but the vector B also takes us east. So the two vector components are along the x-axis. These are collinear vectors. And because they are collinear, we can simply add these together like any two math numbers. So basically what I'm going to do here is I'm going to say, let's say east is the positive direction. So what that means for us is that if I do the math here, in the end, let me scroll this back over here again. In the end, what we're going to actually do is you're going to just pretty much take 9.19 meters, and you're going to add, again, that's to the east, so that's a plus direction. You're going to add in the 4.79 meters. And when you get that, you'll end up adding these two numbers together. Let me go over and get my calculator, and we basically add, let's see, what are we, 9.19 plus 4.79 gives us, it rounds up to, looks like 14 is what it would round up to. So 14 meters, let me do a better job with that, 14 meters in an easterly direction. Now, likewise, in our y direction, we'll notice that the vector A takes us north and the vector B brings us actually south. So these are in opposite directions of one another. So in effect, this is subtraction. I'm going to decide to call, in my case here, I'm going to call north the positive direction. So this will be my positive vector and this will be my negative vector. So mathematically what I'm doing is 7.71 meters in the positive direction. And I'm going to subtract, because again, it's taking us in a negative direction, the 13.2 meters. Getting my calculator up, what do I have here? 7.71 minus 13.2 gives us, let's just say 5.5. So that will be 5.5, and it was negative, so negative means south. I can either say negative or, again, in the cardinal directions, this would be the 5.5 meters south. Now, in a previous video, what we looked at here is that if we had two vectors that were at right angles, let me go find it here. I believe that was right in here. If we had two vectors that were, here we are, where we had these two vectors, and we could draw their them like this, and pretty much what we can do, because we're at right angles, we can use the Pythagorean theorem to find the resultant, and we can also use sines, cosines, and tangents to actually find the angle. So I'm going to go back over, do that real quick, and we'll get a final answer here. Okay, so to kind of summarize, to draw the component for the resultant in the x direction, it looks like this. That's the 14 meters east, and then the 5.5 meters south is going to be this guy right in here. The resultant is always drawn from where we start to where we end. In other words, the tail of the first one to the tip of the second one. To find the magnitude of this vector, we're going to use Pythagorean theorem, because we can do that because we have a right triangle. To find the direction, we can use a tangent function, because again, that works for the right triangle as well. And then to finally write up our solution, or the answer to what we're looking for here, the response, the vector that we're looking for, or the vector addition of these two vectors, is going to be 15 meters. That is the magnitude, and it's at a direction of 21 degrees to the south of east. So copying this up here. Oh, that's not what I meant to do. How about we highlight that? Highlight my answer. Let's get this color. Here we go. And basically, when I look at the work, that what I was trying to do, let's kind of revisit what I was actually doing up here. When I add these two vectors together, the vector A plus the vector B, I end up with the vector R, the resultant vector. My resultant vector is 15 meters at 21 degrees south of east.